So here we are in part 5 of negative sequence made easier. And in this one, we're specifically going to go over the IQ data plus 2. Specifically, I want to talk about this one is a negative sequence voltage relay. Okay, it's looking for a percent unbalance from nominal. We're going to go ahead and that's also listed right here. I mean, we could talk about all these other protections. That's not what I'm trying to do in this series. I'm trying to go over negative sequence specifically. And this one really isn't a negative sequence too much because of the way that it calculates it. It doesn't actually calculate negative sequence. It just does a straight, I mean, it kind of calls it phase unbalance, which is a negative sequence voltage, okay? But the way that it does it is a little bit differently for the math. So in order to figure this relay out, we need two things for every element. We need pickup and we need time delay, okay? Excuse my sloppy writing, that's pick up and time delay. And we need both these figured out in order to test the element, okay? And so the pickup is right here. They explain how to do it. And the protection time delay is set right here. All right. And I'm going to go, I know I'm going quick, but I'm trying to save time. And we've got many things to go over in this relay. So the first thing before we do any pickup identification is we have to identify what the nominal voltage is. If you read this right here, it says voltages exceed percentage of nominal. So how do you define nominal? Well, it's right here. Okay. And it basically tells you that on the back of the relay, there's a jumper that you're going to have to move, but you also have dip switches that are going to line up with that jumper, okay? And what am I talking about? I'm talking about there are a bunch of dip switches here, which, you know, this is a picture out of the manual. This is the physical relay, and this is the right side of that relay. You know, if you're looking at it from the back, you're looking at this side over here. That's what this is. So that the reason I did that is because I wanted you to see these switches. So in the manual, these are the dip switches, and then this is your voltage selection, okay? And this is what it looks like on the relay specifically. To zoom in a little bit, this is what we're talking about with those pins. You can see that this little black piece right here is over that one pin, or that group of pins. And that group of pins, if we go back, you know, it's 480 here, 380 here, 208 something, and then 120. And so that group of pins is this group of pins right here, 208, 220, or 240. That's what we're saying nominal is, okay? So there's that. And then, so that's what they've selected on this one. And then we also have our dip switches, and this is how they look. If you look real close, this direction is on for the switch. This entire block is switch 1. This is in all of switch 2. This is all of switch 3, 4, 5. But there are 8 switches on each one, 8 individual selectors, okay? So what do each of the switches, the selectors on switch 1 do? Well, it's listed in the manual, and all the ones that are applicable to what we need, I've highlighted here. Now, we're going to go over these individually, but I just wanted to show them as a group, okay? So we care about switch 1, 2, 3, 4. We don't care about 5, but we do care about 6. So switch 1, protection delay, on or off, okay? Do we want a delay? If we do, it tells you that you're going to use another dip switch to define what the delay is. But do we want that delay on and off? That basically means instantaneous trip or delay trip. That's what this means. Switch 2. We're going to use these last two that are applicable to us. I went through every single switch on the back of this, and I looked at the names and identified that we don't need them. Okay, so this is other research that I've done ahead of this video, and I'm trying to narrow this down. That's the only reason I know that these are the ones that we need. The manual doesn't tell you these are the ones you need. You have to look and read them to figure out which ones you do need. All right. Detected phase unbalance response. We're concerned with the phase unbalance testing. And what do we want the response to be for an imbalance? And right now, if both of them were in the on position to the right, then on and on is right here. And that means that neither will trip or alarm. So the alarm contacts and the trip contacts will not operate if the phase unbalance operates. If you want the trip only to operate, then you're going to be off on 7 and on 8, which means 7 is going to go to the off position. And now in this position, 7 will, in this position, the trip contact will operate and the alarm contact still will not operate, even though the unbalanced response does. This is handy because they might have it actually as an alarm only. They just want to know that they're overheating their motor, but they don't want to shut that plant down. So, I mean, you might see it in this configuration. Okay, so don't be surprised. But this also tells you which contacts are going to be available for you to identify that trip. Switch 3, well, this kind of makes a big difference, right? If this is off, then everything is off. Okay, so protection functions on or off. You kind of need that in the on position in order for you to test anything on that relay as for when it applies to protection. AC line voltage selection. So remember, we had to select which pin we were going to have, and then you also have to come in here and tell it. Well, I mean, if you think about it, this guy right here, there's 3 options. So you could have it like they have it right here on 208, 220, and 240. I can't read the other 2 numbers. I'm just taking it off of the right here because I know what the selector has to be. And then, well, there's 3 options there. So what is the nominal? Well, here are your 3 options. And depending on your dip switch configuration for slide 1, slide 2, and slide 3, which are these ones right here, that will determine what your nominal voltage is. Okay. Last one is switch 6. And the top is going to be our pickup setting right here. And the bottom of that is going to be our time delay setting, okay? And it's in seconds. There's no curve-based protection. It's just definite time in seconds. You can read the literature there to identify that. Do not think that you just do the top 3 and the next 3. The switch 4 has a watt-hour count reset, and switch 8 is unused. So make sure that you're on the right switch. Okay, so now we're going to go over this example, and we're going to use this as our nominal voltage, which is 120 volts, and our phase detection level is 10%, given by the dip switches here. You can see that's exactly what these look like, and our time delay is 7, okay? So the way that we're going to calculate this, and that's these 3 switches right here. So 10%, and the way that we're going to calculate this is, let's go back and be very specific on how they worded it. It's not exactly super intuitive. So let's just look at this real quick. It says a phase unbalance. This is right here is what we're reading. Is detected when the difference between the smallest and largest line-to-line voltages exceeds the percentage of the nominal line. So if the nominal is 120 and volts, and I told you that it's 10%. Well, then it's going to be 10% of that, which is times 0.1, which is 12 volts. So the difference between the highest and the smallest line-to-line voltage cannot be more than 10 volts. So all we have to do for this one is the input voltages, from A to C and B to C, and then also you have A to B. If, for example, you had 120, 120, and then the difference between the highest is, well, I mean, let's just say the 120 is the highest, and the lowest would be 108. That would be a pickup for unbalance. Also, a pickup for unbalance could be 124, 118, and if 124 is the highest, then the lowest could be, 12 below that, which is 112. Okay, so it says 10% of the nominal, and that's what we would do. And no matter which one of these you would pick, it should ideally be a threshold for pickup. This would be a pickup for the lower range, and this would be a pickup for the higher range. I mean, you could look at it that way, or really, it's also on the lower range because you don't have 2 of them that are the same like they are in this upper one right here. Then once you get done with that, the best thing to do is to always go ahead and, you're going to take these, you would do a state sequencer for your time delay right here, which is 7 seconds. And all you have to do for that is just start at 120, 120, and 120. And then the next state's going to be 140, 110, or one and then 110. And obviously you're going to have a phase unbalance here. Make sure that you're not outside of your thresholds for your under voltage or your over voltage, and you don't want to trip on something else inadvertently, but then this would definitely be outside the threshold, outside the pickup range, and so it should time immediately And it won't be an immediate trip, but the timing will start immediately. You won't have to wait on a pickup threshold because you're already well beyond that, and it should trip at 7 seconds. So hopefully that helps, and we'll see you in the next one.